Welcome to my channel Chemistry Class. Welcome back to Chemistry Class, my dear student. I hope you're doing well. So, in the previous lecture, we discussed the Bronsted-Lowry concept of acids and bases, which explain the concept of acids and bases in terms of proton transfer. But today, we will discuss a more modern and general concept, which is Lewis' concept of acids and bases. So let's explore this concept step by step. Lewis' concept of acids and bases. My dear student, this theory was given by Jean Lewis in 1923, and it explains acid-base behavior even for those substances that do not contain hydrogen ion. Now, according to Jean Lewis, an acid is a substance that can accept a pair of electrons, and a base is a substance that can donate a pair of electrons. This concept focuses on electron pair transfer rather than proton transfer, is in the Bronsted-Lowry theory. Now, definition of acid and base according to Lewis concept. Lewis acid, a substance that can accept an electron pair from another substance to form a covalent bond. Lewis base, a substance that can donate an electron pair to another substance to form a covalent bond. Examples: first one, reaction between BF3 and NH3 reaction. BF3 plus NH3 gaf F3B NH3. Explanation: BF3 has an incomplete octet. It can accept an electron pair, act as a Lewis acid, because according to Lewis, a species which accept an electron pair is called Lewis acid. While NH3 has a lone pair of electrons and nitrogen, it donates an electron pair, so acts as a Lewis base. The electron pair from NH3 is shared with BF3, forming a coordinate covalent bond. Representation: arrow. The arrow shows the direction of electron pairs donation. So in this reaction, the arrow shows that electron pair is donated by nitrogen. Second example is reaction between Ig positive and NH3. Reaction Ig positive plus 2 NH3 gaf Ig and 2 NH3 whole taken 2 whole positive. Explanation: Ig positive accepts electron pairs from 2 NH3 molecules, so it acts as a Lewis acid, while NH3 donates lone pairs, act as a Lewis base. The product Ig into NH3 whole taken 2 whole power positive is a complex ion formed through coordinate covalent bonds. And third examples is a reaction between H positive and OH negative. Reaction H positive plus OH negative gave H2O. Meaning H bond O bond H, simply H2O. Explanation: H positive accept an electron pairs from OH negative, so act as a Lewis acid, while OH negative donates an electron pairs, act as a Lewis base. A coordinate covalent bond forms, producing water. And the fourth example is formation of aluminum chloride dimer. Reaction 2LCl3, reversibly gaf L2Cl6. Explanation: an LCl3 aluminum has an incomplete octet, so it behaves as a Lewis acid. One chlorine atom donates its lone pair to aluminum. It acts as a Lewis base. Thus, a coordinate bond forms between aluminum and chlorine atoms. Concept of electron pairs donation and acceptance. In the Lewis acid-base reaction, the Lewis base donates an electron pair and the Lewis acid accepts that pairs, forming a coordinate covalent bond. General representation: base have lone pair plus acid gaf base gaf acid coordinate compound. Example: NH3 plus BF3 gaf NH3. Let's NH3 a BF3 and arrow represent that one pair is donated by nitrogen. Here, the arrow indicates the direction of electron pairs donation from the base to the acid. Now, comparison between Lewis, Arrhenius, and Bronsted-Lowry concepts. Concept: acid, base, type of transfer. Example: first concept, Arrhenius. According to Arrhenius, acid produces H plus mean hydrogen ion in water, while base, according to Arrhenius, base produces OH negative and water. An Arrhenius concept ion formation take place. Example: ICl plus NaOH gaf NaCl plus H2O. And second concept, Bronsted-Lowry. According to Bronsted-Lowry, acid as a proton donor, base as a proton acceptor. Type of transfer is proton transfer. Example: HCl plus H2O gaf H3O positive plus Cl negative. Lewis concept. According to this concept, acid electron pair acceptor, base electron pair donors. Type of transfer is electron pair transfer. Example: BF3 plus NH3 gaf BF3 NH3. Advantages of Lewis concept. First one, most general theory, applicable to both aqueous and non-aqueous system. Second one, explain acid-base reaction that do not involve hydrogen ions. Third one, helps understand complex formation, catalysis, and coordination chemistry. Fourth one, broadly applicables in organic chemistry. Ag electrophiles act as Lewis acid, nucleophiles as Lewis bases. Limitations of Lewis concept. The first limitation is it is too broad, includes reactions that are not usually considered acid-base. And the second limitation is it does not explain acid strength or quantitative behavior like pH, Ka, etc. A third limitation is it does not distinguish between acid-base reactions and simple complex formation. So, my dear student, this is all about today's lecture on the latest concept of acids and bases. I hope you understand. So, if this lecture will help you, then don't forget to like the video, subscribe to the channel for more chemistry lecture, and share it with your friends. Comments your question below. Take care and see you in the next class, inshallah. Thank you for listening.